So hello guys, I'm Kumar K, your favorite DSA teacher when it comes to solving hard and zero A problems and competitive programming coding contest problems. So today let's try to do things a little bit quicker because we need to rush to the problem today, okay? So guys, the problem is this interesting problem which was asked in biweekly contest 145, okay? We have to solve this fourth question. It had very less submissions, only 200 to 400 submissions, successful submissions from the 40,000 people who participated. Count connected components in LCM graph. Now guys, for this problem you need lots of prerequisites. You need to know very deeply about LCM and GCD mathematical logics. You need to have the basic idea of what is a graph, how to calculate the number of connected components in a graph, and you need to know how to calculate all factors of a number in O of square root n time. So basically, I hope that no matter who you are, you must be having these basic knowledge and basic things should be clear with you. Okay, clear to you. So I've written it here as well that these are the prerequisites. But now, guys, the most important thing is what is the question telling you? Basically, question is telling you that we are giving you an array of all distinct numbers. Okay, we have to create edge between the pair I comma j if the LCM, guys, if their LCM is less than equal to t. So guys, I hope that you know that LCM is the least common multiple. So if the LCM is less than equal to t, guys, we will create a new edge in the graph, and once the graph is created, we have to count the number of connected components in the graph. Brute force solution in n square time is pretty simple, right? In so what you will do, guys, what will be the brute force solution to this? I don't think it's difficult for anyone to know, right? You must be knowing. If this is the given array, let's take this case only. 24839, right? 24839. Okay, there's nothing in the end. First you check this. What is the threshold, guys? Threshold is, I think it is 5. So guys, threshold is 5. So threshold is 5, so t equal to 5. So guys, what is the LCM of 2 and 4? Lowest common multiple. The which is the smallest number, which 2 can also divide, 4 can also divide. 4 is the LCM. So LCM of 2 comma 4 is 4, which is less than equal to t, because you can see t is equal to 5. So you can make an edge from node 2 to node 4. Then let's check for 2 and 8, what is the LCM? 8 is the LCM, which is bigger than 5, so we cannot make the edge. 2 and 3, the LCM is 6, which is bigger than 5, we cannot make the edge. 2 and 9, the LCM is big, so we cannot make the edge. Similarly, guys, apart from 2 and 4, now any other two nodes, their LCM is always bigger than 5, guys, so we cannot make any edge there. Okay, so that's it, guys, we cannot make any edge. So you can see the graph looks like this: one edge from 2 to 4, and then 3, 9, 8, like this, because the other nodes were not able to make any edges. Why? Because when we calculated their LCM, it became greater than t, and our t limit is 5. So how many connected components are there, guys? One component, this second component, then this third and fourth, four connected components. Okay, so brute force solution is pretty simple. It will take n square time complexity. You check all the pairs of the array. If the LCM is less than equal to t, make the edge in the graph and check, and then run a simple DFS or BFS to count the number of connected components in the graph. That much I hope is clear to all of you. Okay, now guys, let's jump to the optimized solution. Okay, so what will be the optimization? Okay, let's go try to think about the optimization. Okay, so optimization is the main thing. You will find many solutions for this, but you will not get the proof why does this work. So my job is to give you the intuitive feeling why it works. So guys, see, we want to merge the pairs I comma j, right? I comma j. Let's say there is an a here, and then there is a b here. Okay, okay, we want that LCM of a comma b becomes less than equal to k. What is the formula for LCM of a comma b? LCM of a comma b is nothing but what? A into b divided by GCD of a comma b less than equal to k. I can rearrange it like a by GCD of a comma b should be less than equal to k by b. That's it. So guys, the problem is now getting solved. Okay, you can assume that, let's say this is index I. Okay, at index I, you know this number is what? Let's assume this number is b. So in constant time you can calculate the k, you already know, and b also you already know, so you calculate k by b instantly. Once you calculate k by b, you just need to check which guys are there in the range 1 to I minus 1, such that their value when divided by GCD of a comma b is less than equal to k by b. If that's true, we can make a pair, right? So it's pretty simple. If you are at index I, calculate value equal to, what will be the value? Value is pretty simple, guys. It's this value. You are at index I, you just calculate k by b. So value is nothing but the threshold, right? Threshold, let's assume k is the threshold, by b of I. Now all guys in range 1 to I minus 1 having bi divided by having let's say all the guys in range 1 to I minus 1, right, having bu divided by GCD of bu comma bi less than equal to VL are all valid to make edges, are all valid to make edges. Okay, are all valid to make edges. Now, so this thing is pretty simple, and guys, I hope that this simple concept is clear to you. So now we are at index I, right? We calculate k by b, right? All the guys here, I'm considering any guy here from index 1 to I minus 1. Let's say its index is u. So, and this guy's value is b. So, b of u is a, right? So, if a by GCD of a comma b is less than equal to this, then that's true. So, that's simple. But guys, what is the trick here? Well, the trick is very, very important one, actually. So, guys, the trick is that you need to little bit, you need to think what's going on. Okay, so what happens when we are talking about GCD? It means there are some common factors in both of them, right? There are some common factors in both of them. So what I mean to say is now, guys, that, see, I know that this thing is k by b, right? Okay, let's assume I have sorted the array and the array has only distinct unique numbers. Okay, we assume, guys, that we have sorted the array and the array has only unique and distinct numbers. So let's focus now what can we do in this particular situation. So yeah, let's focus here. So guys, what I want to focus upon at this particular time is that the thing is that this thing, let's try to focus on it, is that this thing is k by b, right? It's really difficult to explain this, but I will do. It is sorted and all the numbers are distinct, right? Okay, sir. This value is k by b, right? This value is k by b. Now, guys, I'm saying that this b value will have many divisors, right? Let's say b is 14. So, which are the divisors of 14? 1 divides 14, 2 divide 14, okay? And 7 divides 14. Well, even 14 divides 14 itself, okay? So, these are the plenty of divisors, okay? So, guys, let's pick up a factor too, okay? So, we will go factor by factor. We will go factor by factor. So, let's assume that we only want to make the pair with the guys such that uh, this guy's factor is 2 and this a guy's factor is also 2. That's what we want in the current situation. That b's factor is also 2 and a's factor is also 2 and 2 is the GCD as well. Now the things become easy. Why? See, you know the k by b value, right? And what will be the value for this? The value for this will be a by 2, because now you have fixed the GCD. So the trick to optimize is that fix the GCD. The GCD can be what? GCD can be 1, or it can be 2, or it can be 7, or it can be 14. Basically, I know B is fixed. I don't know about this guy. So no matter what is this guy, what can be the GCD? The GCD can be 1, or it can be 2, or it can be 7, or it can be 14. So we will assume one number by, at each step. One we will once we will assume, let's assume that the GCD of these two numbers is 1. Then we will assume, let's assume that GCD of these numbers is 2. Then we will assume, let's find the pairs where the GCD is 7. Let's find the pairs where the GCD is 14. GCD means this number divides B also and A also. And this is the biggest number which divides both of them. So let's assume GCD is nothing but a factor of both the numbers. So guys, for, let's say 14 is given to me. Okay. And now guys, like the trick is that we have to fix the GCD, right? So let me write here. Fix the GCD, which is nothing but the factor D which divides A as well as B. Now guys, the things become very easy. Okay, what do you need to know? VL, you know. And what will be the left hand side value? It will simply be A by D. So if you know the minimum A by D value, minimum A by D value in the range 1 to I minus 1, you can easily say, if there is at least one valid guy with whom you can make pair. Okay, and you can you know easily you can know which guy has minimum A by D value by using hash map. So guys, I hope that you are not a beginner and you understand that the simple trick is that, let's assume that this is a nice looking B. These are the divisors 1, D1, D2 and B. These are the divisors of this number. Okay, you want this less than equal to equality to hold true. Okay, here there will be B by K. When you come here, you already know this. This is index I, you already know this. Now from index 1 to I minus 1, find a guy such that uh, it's A by D1 is less than equal to B by K. This time we are assuming that D1 will be the factor of B also. Obviously D1 is the factor of B, and D1 will be the factor of the number we are trying to find. Okay, so basically D1 will be the GCD. Okay, so guys, it is very easy. When you were at A, you could have seen what were its factors. One factor would be 1, another would be A, another would be D1, something like that. And you can always calculate A by 1, A by D1 and A by A, and you can store them in hash map. Okay, you can store them in hash map. Hash map of D1 should tell you that in this range, which is the minimum value of A by D1 till now. Okay, so hash map of D1 basically will immediately tell you. So I'm writing this thing here also, which you can use, that hash map of D1 should immediately tell you the minimum value of A by D1 in the range 1 to I minus 1. So basically in the range 1 to I minus 1, when you travel all the numbers, out of all those numbers which were divisible by D1, you do A by D1, and whatever is that number, you just push it in the hash map. Basically for each number when you are traveling now, you need to calculate all the factors. Okay, So this way, basically, for each number you will exactly know, guys. Okay. बेसिकली जब मैं यहाँ पर समझो यहाँ पर है 28, तो मैं 28 को देख के इग्नोर नहीं कर दूंगा। 28 के जो भी फैक्टर होते हैं ना, 1 हो गया, 2 हो गया, 7 हो गया, 8 हो गया, 4 हो गया, ये जितने भी फैक्टर्स है मैं कैलकुलेट करूंगा। इन हाउ मच टाइम? इन स्क्वायर रूट ऑफ 28 टाइम आई विल कैलकुलेट दैट। एंड देन गाइज व्हाट आर द डिवाइजर्स? 28 by 1, 28 by 2, 28 by 7. These all values I will calculate and I will push in the hash map, that hash map of 1 is 28, hash map of 2 is 14, hash map of 7 is 4. So hash map of these values are giving me, for this particular B, I will instantly know the minimum possible value of A by D1 if I am considering the D1 divisor. We are considering that B has, let's assume it has these divisors, okay? Let's say D3 and let's say B. So I'm assuming that, let's say, we only consider the numbers which have D1 as the factor of B and D1 is also the factor of A there, okay? This much we are considering till now. Now guys, if you know the guy whose value is minimum in A of D1, obviously there is highest probability that it will be less than equal to K by B. So guys, an edge can be made from here to there. Now guys, the trick is, only this needs to be considered, other numbers don't need to be considered. Okay, so let me explain what I'm trying to say. This is a sorted array, right? And this is a B, right? And this is A1 and this is A5, right? Now this value is what? B by K, which is less than equal to, let's say, A1 by, we are considering the factor D1. Okay, so D1 is getting, let's assume, divided by this also, by this also, by this also. A1 by D1 less than equal to, let's assume, A5 by D1, because it is sorted now, less than equal to B by K. Okay, so guys, which is the minimum A by D? Minimum A by D is this first guy, which is A1 by D1, right? So we are making edge only between A1 and B. We are A5 to B edge we are not making. So what is the trick? Why are we making the edge only with the minimum guy? Though we should make the edge with this also, na, so that the graph looks wholesome. Why? So this is the main trick which people wanted to know, which no one explained, but I will explain you, don't worry. So basically, why the edge of B is only made, first of all, the array is sorted, okay? Sort the array. Sort the array is a commonsensical thing. You have to do it. You have no other option, okay? Why the edge B is only made with the guy with the minimum value of A by D. Other guys in range 1 to I minus 1 can also have A by D less than equal to K by B. But we make edge only with the minimum A by D. When min A by D, obviously minimum A by D, guys, should be less than equal to K by B. Why do we do that? So explaining that in the video, okay? Explaining in the video. So what's going on here? Okay, so let's try to see what's going on, okay? So let's try to take a pretty example, okay? So I take a 4 here, I take a 6 here, I take a 8 here, I take a 12 here, I take a 14 here, okay? So guys, lovely people, let's say this is my B, okay? Let's say my threshold is 28, okay? So guys, what will be my, if I am here, I want to make some edge, okay? And I have sorted the array. So basically I want to make the edge of 14 with the guys further ahead of me, okay? So let's do the trick. What will be the trick is that let's write it as b by k, right? K by b, right? K by b. Yeah. So k by b. So let's write it here as k by b, which is 28 by 14, which is 2, right? So guys, this should be greater than equal to, yeah. So guys, what are the factors of 14? 1, 2, 7, 14. So guys, there are so many factors. Let's consider one factor, 2. So guys, now let's try to make the edge where our divisor is also 2 and the other guy divisor is also 2 and 2 is the GCD. So we are fixing the GCD as 2. See guys, there are multiple options. GCD of this guy with other number can be 1, 7, 14, but we have to fix one number at a time, right? So let's fix 2 as the GCD. So fixing the GCD as 2, the divisor is 2 guys and the GCD is also 2 now, okay? With the other number which is going to be. So now what will happen? What will happen? You need to calculate a by d minimum value, right? So this will be 4 by 2, this will be 6 by 2, this will be 8 by 2, this will be 12 by 2. Guys, which one is minimum? This one is minimum, right? This one is minimum. So 4 by 2 is what, guys? You know that 4 by 2 is 2. This is also 2 and this is also 2. 2 is less than equal to 2. So you can make an edge. This basically means that you can make an edge from 4 to 14. And guys, done, you will go ahead. Now guys, a question will come in your mind. Sir, why did you not check what is happening between 6 and 14, 8 and 14, 12 and 14? That question is coming in your mind, right? That, sir, why did you make the edge of 14 when you considered the divisor as 2? These guys could have been eligible, but you took the minimum guy. Why? Guys, the logic is that for this current number, if you consider the GCD as 2, I will consider each divisor one by one. But if I consider the GCD as 2, this is the minimum guy which can make the pair with us, right? So we don't need to care about other values. Why? Because the other values like 6, 8, 12, we consider that these guys also have the divisor as 2. Okay, I'm only showing you the values which are bigger than 4 and having the D as 2, and potentially the divisor is GCD is also 2 with 14. Okay, so guys, what is the speciality? That these guys will automatically get connected. This 6 will get connected to 4, 4 will get connected to 8, and 4 will get connected to 12. So this will become a connected component. See, 14 is connected to 4, and now 4 is connected to 6, 8, 12. So you don't need to check what is the relation between 14, 6, 14, 8, 14, 12. Why? They are already connected, so no need to make extra edges. They are already in a single connected component. That is the way to make the problem solution efficient, guys. Why is the problem solution now efficient? Because तुम extra edges नहीं बना रहे हो. जितने जरूरत है कम से कम edges में connected component create हो रहा है. Clear? So basically, once the edge from 14 to 4 is created, it is guaranteed that all the smaller numbers whose divisor is 2, and which will those numbers whose GCD with 14 will be 2, they are already joined with the smallest number. They are already joined with the smallest number. They are already joined with the smallest number. How? Some people will ask, sir, what is the proof that they are already joined with the smallest number? Well, I will show you. Don't you worry. My proof is that if 14 is joining 4, na, you don't need to check the relation of 14 with 6, 8, 12, because 6, 8, 12 are already engaged to 4. How? They are already joined with 4, not engaged. Sorry, not engaged. Why? What was its k by b value? Its k by b value was 28 by 14, right? What is this guy's k by b value? It is 28 by 12, 28 by 8, 28 by 6. Okay, so you see what is happening? These values are now increasing. See, k by b, k remains constant, b is becoming smaller. So if b is becoming smaller, it means k by b is increasing. If you check for these numbers now, they have a big k by b, very big value of k by b. Okay, but the minimum a by d remains the same now. We are assuming that the GCD of all these numbers with the a, minimum a by d will always be 2. Okay, we are considering the divisor as 2, right? So a by d is going to be what? Minimum a by d. Minimum a by d will be 4 by 2, which is 2. And these guys are increasing their ranges of threshold. So obviously these guys threshold will be bigger than equal to 2. समझे बात को? So what I'm trying to say is that if 28 by 14 is greater than equal to this guy's a by d, which is 4 by 2, then it is sure that 12 by 14 will also be greater than equal to this. They will make a pair. 8 by uh, sorry, 12 by not 24, I wrote the wrong value, sorry, k by b, right? So threshold is 28. 28 by 12 will also be greater than equal to this. Then 28 by 8 will also be greater than equal to this. And then 28 by 6 will also be greater than equal to 6. So automatically, when you came at these numbers, you must have made the pair with the minimum guy. So hopefully guys, it is clear to you that this is the brilliant logic of the problem, is that, see, whenever you are at a current number now, you have to take a leap of faith. You have to say that yes, guy, and I can make bond with other numbers which are having divisor as 1, and I am also having divisor as 1. Okay. Now just assume that the GCD of these guys will always also be 1. So considering such a set of numbers, and you will check what is happening. Then guys, it can happen now that the guys you're making a bond with, it can happen that the GCD is 2, right? So consider that one. GCD can be 7, GCD can be 14. Other numbers you don't need to consider, because no numbers GCD with 14 can be 8, because 8 is not a divisor. So like this, for each number you have to calculate all the factors, and in the hash map you will know which is the minimum a by d. So O of n square root n is the efficient solution for this problem. And that's it guys. So O of n square root n, which is efficient actually solution. For each b, calculate all its factors and assume, you calculate all its factors and assume that this factor d is the GCD in making, and also you only focus on finding the a on the left which are divisible by d. Okay, now guys, someone might say that, sir, what if even after doing all this, what if, some people can think, okay, like that this guy is divisible by d, this guy is also divisible by d, guys, sir. Okay, okay, great going. But it can happen that, sir, that the GCD is even bigger than that, right? Yes, it can happen, but still you don't need to worry. Still this algorithm will work. Why? Because eventually you will reach that bigger number also when you are going through all the divisors of the given number. So it's perfectly fine when you go through all the divisors and you just assume that this divisor is your GCD and do the job. It makes the things a hell lot easier. This is a trick which should be known in the OE and CP questions, that you interchange the divisor and GCD things. So guys, if you are one of the people who are looking for these kind of high level training, they want to master DSA, OACP, they want top 500 companies referral, personal mentoring, one-to-one mentoring with me, and lots of support and help. We have so many selections, you can see. So if you want to join the program, the link to the cohort which has newly started is in the description. Okay, and you guys, congratulations if you had the power to watch and understand the solution. Okay, all the best.